All right, this video is going to go over notes 9.2a, which is the intro to rationals. They are tricky, so let's go ahead and get started. The first thing to know is the parent function. So you can just choose some random coordinates like -2, -1, 0, 1, 2, and you're going to be plugging them in right here. And so like if you plugged in -2, you would get -1/2. So -0.5, same thing. If you plugged in -1, you'd get -1. If you plugged in 0, 1 over 0 is undefined. This is going to be really important to realize. When you get undefineds here, it's a vertical asymptote. I'll tell you more about what that means here in a second, but let's keep going. If you plugged in 1, you would get 1 over 1, which is just 1. And then the last one would be 1/2 or 0.5. So if you threw these on a graph, you'd get something like this. Now that's not very helpful to graph, so you really need to know the shape of a rational. Rationals look like this. Hold on, my pen was off there. Okay. Looks like this and like this. Okay, the pen is still off there as well. That's the best it's going to be. Good enough for me. All right. So they look like this. There's two sections of line. And so generally, there's going to be a vertical asymptote wherever your undefined is. So that's at x equals 0, there's a vertical asymptote. And then there's also going to be a, I'll do it in green, horizontal asymptote as well. So this one would be at y equals 0. All right, these blue and green lines are critical if you're going to understand rationals. They have vertical asymptotes and they have horizontal asymptotes. All right, so when you talk about like HK, your shifts like usual, they are what's shifting the center of these asymptotes. So your H, if you shift left or right, you're shifting your VA, your vertical asymptote. And your K, if you shift up or down, you are shifting your HA, your horizontal asymptote. All right, A is going to be either be like a stretch or a compression. I know this doesn't make that much sense yet. Once you see me actually do some of these, like these three down here, hopefully it'll make more sense. In behavior are where your arrows go. I'll explain more about that in a second too. I don't know what they're trying to get at here with vertical asymptotes, like a blank field, force field. I don't know. The blank at the vertical asymptote have blank. The blank of the denominator determines the blank of the blank. Guys, you don't need to know all these things, all right? You need to know the basics, which is you need to know the shape of the graph. It looks like that. You need to know that there's VAs and HAs that'll break up the line into multiple pieces. And if you know those things, you're probably good to go. So like, here's how I would approach number 1. I would look at the problem and I would look at the denominator and realize that if that denominator was 0, I would throw an undefined, right? So, and if like x was 1, I would have 1 minus 1, which is 0, and it would be undefined. So at x equals 1, there is a vertical asymptote. I should probably match colors. Let's do it in blue. I know there's a vertical asymptote at x equals 1. And then I would look at this and realize I shifted up 2. So my HA, instead of being at 0, now it's at y equals 2. Let me make this blue, x equals 1. So my VA was at x equals 1. My HA was at y equals 2. So this line is just going to look something like this. And so now if you talk about your domain, well, the only thing that breaks up the domain, which is your all possible x values, is this vertical asymptote at x equals 1. So you have two sections of line. You have a section of line from negative infinity to that VA of 1, unioned with, you have 1 to positive infinity. So here's what I mean by this. This first section, negative infinity to 1, is this section right here. The second section, 1 to infinity, is this section right here. All right, so then your end behavior is wherever your arrows are going to. If you look at this line, you need to realize that these arrows are going to level off on this green line. That green line's at 2. So your end behavior here, if you go left or right, so if you go x plus minus infinity, your y value is going to go to 2. So that's how I would have done that problem. Yeah, you probably could do like the whole table thing and choose your points based off of your shifts, et cetera, but it's not always necessary to do something like that. So let me show you what I mean on the second one. The first thing I go after on a rational function is the vertical asymptote. I look at this denominator here. I notice there's no shift or anything, so my VA never shifted off of this x equals 0. So I know my VA is x equals 0. Now your HA is the second one, so it shifted up 3. So y equals 3 is going to be my HA. So my line is going to look something like this. All right, and so now I would just be like, my HA was y equals 3. My domain, this section of line runs from negative infinity to the vertical asymptote of 0. And then this section of line runs from that vertical asymptote of 0 to positive infinity. And your end behavior, these arrows are going to level off at that green horizontal asymptote of 3. So if you go either positive infinity or negative infinity on your x, your y value is going to level off at 3. All right, this last one. This last one's a little bit different. I would still go after my vertical asymptote first. So I would realize that x equals 3, because it would throw an undefined, is my vertical asymptote, x equals 3. Okay, now I'd go after my horizontal asymptote. It shifted down 2. So y equals negative 2. All right, now you can't just assume that this line looks like this, same as the others. It doesn't. There's a negative out in front. That's going to reflect it. And so when it reflects it, the side that would have been here flips, and now it's like this. And the side that would have been here flips, and now it's like this. So this line is kind of oppo from the others. And so now if I was answering domain, this section of line runs from negative infinity to my VA of 3. And then this section of line runs from that VA of 3 to positive infinity. And then lastly, the end behavior, these arrows are going to level off on that green line. So if you go plus or minus infinity on your x, that means go left or go right, those arrows are going to level off at that HA of negative 2. So that's how you would actually graph those rationals. So hope this video helped.